All right, so we're going to jump to 54. Instructions are going to stay the same. It says to do it over a 2-period interval, but we're still just doing the one, so just like one cycle through for all of them. So 54, y equals -3 plus 3 sine of 1/2 x. So what do we notice about this problem?
My -3 is in front of sine.
But where should it be in our normal situation?
At the end.
Yep, so I'm going to take this and I'm going to move this over here just so that we don't get confused with it. So y equals 3 sine of 1/2 x minus 3. Now, the other thing to notice is, what is this minus 3 telling us to do as in the graph?
Go right.
So you said exactly what I wanted you to say, because I want to show you why that's not right, okay? So when we have it at the end, okay, for it to move right or left, there has to be parentheses. Okay, if there's no parentheses, that's an up or down.
No parentheses.
So this one is going to be going down 3, which we'll write all of our other stuff and then I'll write that. But I wanted to point that out now because that's another thing people tend to get confused with. So amplitude is what?
3.
3, period.
2 pi over half.
2 pi over 1/2. And I keep change flipping it. 4 pi. So then the scale would be what?
4 pi over 4, which would be pi.
4 pi over 4, which is pi. Probably the easiest scale we've had for any of the ones we've done so far.
Yeah.
And then we said this one is going down 3. So I'm going to set up my graph here. So since I know it's going down 3, I'm going to go ahead and do the little tick marks down as well. So this will be at -6 because I know that's... So normally I don't put all the extras, but since it's going down, I'm going to throw them in there so it's easier. Then I'm going out to 4 pi. So that scaling is nice and easy, just increments of pi. So where does sine start?
0.
Yep, sine starts at 0. If you ever forget that, look at your unit circle and look at what the sine of 0 is. And you'll remember. So then at pi, it's at 3. 2 pi, it's back at 0. 3 pi, we're at -3. And 4 pi, we're at 0. And I'm just going to remind you, make sure that when you're doing these curves are rounded, not like a V, okay? It doesn't look like this when you're doing it. Okay, that would be an absolute value graph, not a sine or cosine graph. All right, so then down 3. So I'll do that here. So every point is going down 3. So this one's going from 0 to -3. This one's going from 3 to 0. Here, 0 to -3. From -3 to -6. And from 0 to -3. All right, this next one I'm going to have you try on your own. Okay, just to see how we're doing, and then we'll go over it together before I give you your problems for homework. So 58, 4 minus 3 cosine of x minus pi. So this one has more happening to it. Okay, this has a little of everything. Okay, every type of translation or movement that we can have, this one has. So write down all the things that are happening. So do like those steps like 1 through 5. So write your amplitude, period, scale, any shifts and reflections that might be there, and then pause before you graph it, because I want us to check that we have all that right before we graph it. Also, there should be a y equals in front of this, just so you know. Not that it's going to really change anything, but... All right, what's my amplitude? 3. What is the period? 2 pi. Okay, it would have just been over 1, so just 2 pi. The scale?
1/4.
Well, if the period is 2 pi.
I mean, half pi.
Yep, pi over 2. And then what else is happening to this graph?
It's reflected.
It is reflected because of the negative in front of the 3. What else? There's 2 more things. Yep, right pi. And what else?
Goes up 4.
Up 4. All right, so that's all the things that are happening. So now use that and graph. Make sure you pay attention to the fact that your scale is pi over 2, but all your points are moving to the right pi. Okay, so that's moving 2 increments every time when you do that. And I would say reflect the graph before you do the shifts, because I feel like you might get confused if you do the shifts first. If you did it that way, that's fine, but That's my recommendation. Do we have a graph? Or at least maybe along the right track.
I have 3 of them. Is there 4 of them?
Well, it depends on how you did it. If you started with the reflected graph, then you'd only have 3. I mean, or you can do all your shifts at once. So you could do the right and up in one graph if you wanted to. I did them all separate so you can see the shift and how it works, but there's different ways you can do it. So you had a scale of pi over 2, so every little dash mark was pi over 2, so you'd have to go 2 dashes over to the right for every single point that you had. Give like 1 more minute and then we'll go over it. going to put up my graphs. All right, so blue is the initial, like, parent function for this graph, okay, with no shifts or anything. It's cosine, so I started at 3, come down like this, okay, so the blue line that's partly covered up is the initial, okay. The next thing I did is I reflected it over the x-axis. So that means that any point that's in the top quadrant needs to move to the bottom. So this went from 3 to -3. Okay, the ones at 0 get to stay. Nothing's happening there. So that one got to stay. This next one was down here at -3, so it flipped up to +3. This point at 0 got to stay. And then this one up here that was at 3 gets flipped over to -3. So that's the reflected one, the red one. Then we have the shift right, so I did that one first. So this point went right pi, so I went pi over 2 pi, so that's over here. This point I had to go right pi, so I take it and go all the way over to 3 pi over 2. The point that's at pi, I took it all the way over to 2 pi. Point here at 3 pi over 2, I took to 5 pi over 2, which if you didn't write that that's what it was, as long as you had the little tick mark there, that's fine. And then the last point down here at 2 pi went over to 3 pi. So the green graph is the one that shifted right pi. And then the last thing I did was I shifted it up 4. So I took every point and I just went up 4 tally marks there. And so the point that was at -3 is now at +1. The point that was at 0 is now at 4. Yeah. Then the point that was at 3 is up here at 7. Then this one that was at 0 is at 4. And then this one over here that was at -3 is at +1. So the purple graph is my final graph. So if you had done the reflected graph to begin with, you could have said, well, I know cosine starts at +3, but I know it's reflected, so I'm going to start it at -3 and work my way up instead. That's fine too. But when I'm showing them, I like to show like each like step by step of it. So, let's do this. These are going to be your homework problems, but I've gathered that y'all have something that you need to study for. Okay. That's what we'll do. Monday, you can do these in class. Okay. Tuesday, so that way if you have questions while you're doing them, you can ask me, and that way you're not, doing them all wrong over the weekend or something. Tuesday, we'll review, and we'll move the quiz to Wednesday. If we have time after that, we'll work on the graphs that go with 6-5 and 6-6, but if we don't have time, then we'll just do them Thursday. And then we'll do the little quiz thingy that on the graphs on that Monday, tentatively. So, because, we're not pushing for the the test just needs to be before spring break, so, otherwise we're only going to get, one section in tops, so, anyways, that'll be the plan.